So, excuse me, the last section I'm going to recap for you guys is 10.4, talking about inscribed angles. And so inscribed angles, the angle of the vertex is on the circle and the sides are chords. Okay, so the vertex is on the circle and the sides are chords. That is an inscribed angle. Intercepted arc is the arc that's inside the inscribed angle. And what we discussed with the relationship between the angle and the arc is that the angle is half as big as the arc. So remember, the angle is the smaller one. The angle is the measure of the angle is half as big as the measure of the arc. Keep in mind the difference between a central angle and an inscribed angle. Okay, central angle, the vertex is on the center point. The measure of the arc, the measure of the angle are the same. Inscribed angles, the vertex is on the circle. The measure of the angle is half of the arc. Okay, keep those two straight. All right, so then just a couple theorems that we talked about. If two inscribed angles intercept the same arc, those two angles have to be the same. So this angle and this angle are both inscribed angles. They have the same arc inscribed in they have the same intercepted arc. They're the same arc inside of them. So this angle is half of this arc. This angle is also half of this arc. The only way for that to happen is for those two angles to be the same measure. And then if an inscribed angle intercepts a semicircle, so if the arc inside the angle is a semicircle, which is 180 degrees, the inscribed angle is a right angle, half of that. Okay, so here we're trying to find the indicated measures. So first of all, we were trying to find the measure of angle T, which is this angle right here. It's an inscribed angle, and it's half of the arc over here, so angle T is 40, or half of 48, which is 24. Okay. Then we're looking at the measure of arc QR, which is over here. Now, this arc actually isn't inside any angle, but what we can do is we can figure out this angle right here is 50, which means this arc over here has to be 100, because this is an inscribed angle. The arc inside of it has to be 100. So if TQ, arc TQ is 100, arc QR has to be 80 because of that diameter right there. Half the circle is 180 degrees. Okay. Here we're asked to find the measure of arc RS. So this angle right here, angle U, is 31 degrees. So RS has to be, angle U has to be half as big as that arc. So that has to be 62. Angle STR has to be 31 because it's half of that. So 31. And then you're asked, what do you notice about those two angles? Angle T and angle U. And we can see that they have to be the same measure, or they're the same measure. They're both 31 degrees, which fits into that theorem that we talked about. Because they intercept the same arc, so they have to be the same. Alright. In this example, we're trying to find this red arc over here, which is arc AB. We know these two angles, and we know this part of the circle is 115. Okay, what you can see about these two angles is that they're inscribed angles. Okay, the vertex is on the circle. So our arcs have to be, oops, I'm going to change colors here. The arcs have to be twice as big as those. Okay, so this angle right here is 100. So this arc from B all the way over here to D has to be 200. Okay. And we can also say that since this is 90, that's this angle right here, from A all the way around to C has to be 180. So that's what this first thing says. BCD is 200, and arc AC is 180, or you could call that ABC. Okay. Now, what that allows us to do, the only part, knowing that this is 180 doesn't necessarily directly help us find arc AB, at least not yet, because there's a lot of different ways to get that 180. We don't know that B is in the middle, and actually we'll find it's actually not. So it could be, it's possible that it's 90 and 90. It's possible that it's 180, or 110 and 70, or 127 and 53. So just knowing that from A all the way around through B to C is 180 doesn't necessarily give me AB. Okay, but I do know that from B to C to D is 200, and from just C to D is 115, which means that from just B to C has to be 85. Now, knowing that this section is 85, we can say that this section has to be 95. All right, last thing we talked about in this section was the idea of inscribed polygons. Now, inscribed angles are angles where the vertex is on the circle and the sides are chords. An inscribed polygon is basically a polygon where all of the vertices, all of the corners are inscribed angles. So all of the vertices are on the circle. That's an inscribed polygon. And then the circle that the vertices are on is called the circumscribed circle. Okay, and the one thing we discussed in class is that the only way to inscribe a quadrilateral inside of a circle is if the opposite angles are supplementary. Okay, so here we have this one, and so we know that the 80 plus the x has to equal 180, and we know that the 75 plus the y has to equal 180. So if we set those up as two equations, so 75 plus y equals 180 and 80 plus x equals 180, we get that y is 105 and x is 100. And we'll just do one more example of that, and then that'll be all for this recap. So here we have opposite angles. So 2a plus 2a has to equal 180, and 4b plus 2b has to equal 180. And again, we write those. 2a plus 2a is 4a. Divide by the 4, you get 90 for a, or excuse me, 45 for a. And then 4b plus 2b is 6b, so you get 30 for your b. All right, that's it for this recap. Hopefully that helps you when you're preparing for the test. Let me know if you guys have any questions.